and you will need to either check your internet and so forth. Okay.
Okay.
Okay. So let's continue. Chapter 10. Evaluation tools for safety and risk analysis. Okay. So this will be a brief chapter. There's only 2 learning outcomes for this chapter. Okay, and it says here, after studying this chapter, you should be able to discuss the different hazard identification methods and explain the selection of hazard evaluation methods. Okay, going to zoom out a bit. It was a bit big. Where's the zoom out button there? Okay, that's much better. Okay, so the introduction. It is all well and good to have a safety system in place with all the documentation and safety from management, but if the system cannot be supported by evaluation tools and techniques, the system will fail. Okay. Therefore, safety professionals must ensure that they keep reading and constantly stay up to date with new techniques and tools to ensure that we can identify hazards and the associated risks. Okay. There are a vast number of tools available for the industry dependent, okay, a safety professional can use. And in many cases, they can be complex, okay, sometimes requiring training. So this chapter will consider the most frequently and widely used tools for hazard identification and evaluation. Okay, so the tools that we are going to discuss in this chapter include the what-if analysis, failure mode and effect analysis, hazard and operability analysis, the tree analysis, and human reliability and cause and effect. Okay, so that is 1, 2, 3, 4, 6 different types of tools you can use, okay, to identify hazards. Okay, so what is the what-if analysis? I'm not going to go into detail with the theory here. I'm going to move straight down to the example. Okay, so we will do, I will just talk about the description and then we're going to go down to the example. Okay, because by now you should know the difference between a hazard and a risk. Okay, so this is just going to show you a different way to identify those hazards and those risks. Okay, so the what if method uses questions. Okay, the team questions each step in a process, determining weak areas where hazards can occur or where the system deviates from the intended design. Okay. So the questioning aids the team to identify the possible accident situations. All right. It is used to obviously identify hazards or consequences that are applicable to a specific activity or process you are embarking on. Okay, in many instances, it is used as an initial hazard identification method. Okay, so what if method usually starts off via a conversation. You're standing there next to a scaffold and you start discussing with your colleague, what if the individual falls off the scaffold? What if the scaffold falls or collapses? Okay. Just talking about the what ifs is a way of identifying the hazards, and that also comes from your industry experience. Okay, so this is a type of a little risk assessment on the what if analysis. Okay, and here we can talk about, for example, tiling a floor. Okay, so let's look the process step. Clean the surface to be tiled. Now that's obviously your activity, you need to clean it. Okay, so when you're cleaning a surface, What are you usually using? You're usually using chemicals, also referred to as hazardous chemical substances. Okay. Now, what could go wrong? We talk about the what if. What if the cleaning products spill? Okay, what if we inhale those cleaning substance vapors? Okay, what is going to happen? So what will the consequence be? Okay, you might have a slip and fall. All right, you might have a skin burn if the chemical comes in contact with your skin. Okay, how are we going to control this and mitigate it? We're going to ensure that it is handled by competent individuals and the chemical is only handled by supervisors on site. Okay, and to ensure that we have the correct PPE when using these specific chemicals. So it is a very straightforward analysis. This is the analysis I use. I use the what if analysis. Why? Because I have ample industry experience in the construction industry. So when I have discussions with my supervisors and managers on site, we are easily able to identify from our experience the what if scenarios. Okay. So that is the what if analysis to identify hazards. Okay, so what is the second one? The second one is called failure mode and effect analysis. So what is the purpose of this type of analysis? Okay, it is a step-by-step method used to identify potential failure modes for a design product or a service. The effect analysis determines consequences for each failure mode. So here you're going to be looking for the failure of an activity that will result in risks and consequences. Okay, these failure modes can directly or indirectly contribute to situations. Okay, so let's look at the FMEA, the failure mode and effect analysis. Okay, for example here, okay, table 10.2 in your textbook is saying we're going to be using a kettle, okay? As you can see, the risk document, analysis document is slightly different to the what if analysis document, okay? It is more impacted and detailed with the steps. Okay, so you're using a kettle. For example, you're making coffee, okay? How are we going to go about doing this? We're going to fill the water, the kettle. We're going to turn it on with the electricity. It's then going to boil, okay? And then it's going to go off automatically after it has heated to the correct temperature. Okay, so those are the steps included in just using a kettle. So the failure mode will then identify each item on your activity list. As you can see, the 4 items we've stated here are now listed under the functions. Okay, so it is very detailed. Okay, so let's look at the what could go wrong when you are filling the kettle with water. Okay, maybe the lid does not open. You're then unable to fill the kettle with water. Okay, the same goes for if you're boiling the kettle. Okay, perhaps the kettle does not heat up. What is the effect of it? Water does not heat up. Okay, therefore the heating element was not connected. Okay, so you are looking for the failure and you are looking for the effect of that failure. Okay, this is not a very popular tool to be used. We mainly like to use the what if analysis in the construction industry. However, if you're obviously in a specific industry that likes to use failure mode and effect analysis, for each tool that you will use, you will then need to state this. So in another example, if you're going to be using a drilling machine, then for the system, you will then state drilling machine. Then for the steps for the drilling machine, you're going to say plug in drilling machine, or if it's a cordless battery operated drilling machine, you could say switch on drilling machine, and then you can say, wait, before we switch on the drilling machine, insert drill bit first, then we can switch on the drilling machine, and then we can drill, okay, into a wall, and then we can or unscrew a screw from a wall, and then we can switch off the drilling machine. Now those steps used in that drilling machine from start to end, you will then list under the item and function, identify what might go wrong. For example, the drilling machine does not turn on, or the drill bit is loose, and what is the effect of that? You cannot remove the screw from the wall. Okay, so that is a second example. Now the third one that we're going to be talking about is the hazard and operability analysis, HAZOP. Okay, HAZOP. Let's get down there. Okay, by now you guys should know everything about identifying hazards and risks, because I think I have given you nice detailed examples in the previous units. Okay, so the purpose of HAZOP. Okay, so this is a technique, is based on theory that assumes risk events are caused by deviations from design or operating intentions. Okay, it is a systematic method used to identify potential hazards and operational problems through the use of guide words. Okay, so let's look at that. Okay, so here their example they are giving us is the process of tiling. Okay, what step in the tiling process are we going to be looking at? Cutting the tile to fit. Okay, perhaps we're tiling a floor, and now we need to cut a tile to fit a corner piece. Okay, here it says cut tile to correct size and shape. Okay, so here we need to look at the words less and more. Okay, what are we actually identifying when we're talking about guide words? Okay, we're going to be looking at the way we go about the deviation. So here it says cutting tile less than required measurement. Now the guide word comes from the deviation. Can you see the guide word says less and the deviation word is less? So the guide word is just a short one-word summary of what the deviation is. Okay, so you're cutting the tile less than the required measurement that you need to add, okay, which means you've cut the tile incorrectly. Okay, so the word for the guide would be less. Okay, what could cause this problem for you to be cutting the tile to the smallest shape instead of the correct shape? Perhaps it was because you never took the correct measurements. Okay, so this one is slightly more complicated. It is laid out differently. So to ensure that you fully understand it, make sure you look at this example. Okay, so maybe you've cut the tile bigger than the required shape. Okay, so the guide word and the deviation will be more. Okay, can you see here the guide word is more and your deviation is more. So on this table, they should have actually swapped these two columns around. You should initially start off with your deviation. Then you should go into your guide word. Okay, it might be complicated now because it's starting off with your guide word, and now you're like, where do we find this word? It's actually your deviation. So you have your deviation first, okay, and then you choose the word that best pulls out and describes your deviation, and that becomes your guide word. Okay, and then obviously you have your possible causes as to why there was that specific deviation. There's always a cause and effect. Okay, always a cause and effect, which you will know from identifying your hazards and the consequences of that. Okay, so let's look at this one a little bit more complicated. From the same example, just scroll down onto the next page. Here, a deviation could be cutting towel as well as floor below. That just doesn't sound good. Okay, that is cutting towel as well as floor below. I'm assuming here, okay, so you're cutting the towel and then by accident you've cut the floor underneath the towel. Okay, so that means your blade has now gone through the towel and the floor. Now you've damaged the floor. Okay, so this deviation is just worded strangely. Okay, so you've cut the towel, now you've accidentally cut the floor underneath the towel. Okay, so here your guide word could be as well as, which I don't agree with, but obviously each to their own. To the author has chosen this of the textbook. You could also say a guide word could be floor below. Okay. What caused you to cut both the towel and the floor below? It was from accidentally placing the towel in the incorrect position, which allowed the blade of the towel cutting machine to cut through and damage the floor. Okay, so that is the has of. This one is obviously slightly more complicated. Okay, so the fourth one is the tree analysis. Okay, this word shouldn't be new to you. We have, I think, spoken about it in 3 or 4 chapters before this. Okay, so a tree analysis are methods that employ graphical tree structures. Okay, very graphical illustrations of the steps and processes. This aids the user to identify possible causes and failures working from or towards a certain event. Okay, so it says here we have event tree analysis and fault tree analysis. Okay, so there are 2 different tree analysis tools to identify hazards, event tree and fault tree analysis. Okay, so here it says the event tree analysis uses a forward logic inductive approach, while the fault tree analysis uses a deductive, a backward logic approach. So let's look at those examples. Okay, so the first one is going to be the event tree. Okay, ET, event tree analysis, ETA. Okay, is that correct? By me saying that, yes, ETA. Okay, so the initiating event of a fire starting in a
Angela, where are you? Where are you now?
Then please unmute your mic. Seems like your mic is mute. Can you unmute your mic, please?
Hello, guys. Where's that? Angela, are you there? Angela?
Sorry, guys. I just saw now that it went muted. Can you hear me now?
Yes, we can hear you.
Yes, we can hear you now.
Okay.
We can hear you now.
Okay.
Yes.
So
Yes, we can. Yes, we can.
looking at the ETA event tree analysis. Okay, are you with me?
Yes, we're with you.
Okay. So let's look at the fire starting in a building. Okay, so here it is, as you can see, very different. Okay, So this hazard analysis, okay. Your initiating event, as you can see further down, it's saying fire in building, okay? Now, there are calculations involved on this hazard identification, okay? So the fire in building is the first event, that is the activity, okay? So what could go wrong here, okay? Here it is saying there could be the fire is going to be detected, okay, which is essentially the mitigating measure, okay. So the fire could be detected, yes and no, okay. But if you have a fire alarm in the building, it will detect the fire. If the fire alarm is broken and not working, it is not going to be detected. So it's going to give you a completely different consequence. If you can follow the dotted line where it says false at the bottom by 0.1 here. Okay, so fire in the building. Here at the top of the table is saying the fire can be detected, and that is two outcomes, yes and no, true and false. Okay, so if the fire is not detected and we follow the word false, it's saying here under consequence there could be severe damage and loss of life. Okay, so that means that no one is going to come help you if the fire is detected by the people within the building and you have the potential to burn because there is no detection and help on the way. But if the fire is detected and we follow the word true, okay, you can see that it comes with a different set of initiate or activities. Okay, so the fire is detected true. The next activity would be the fire alarm sounds go off. Okay. If the fire alarm sounds go off loud and properly and we follow the word true, it then means that the sprinkler system can be activated. Okay, if the sprinkler system is initiated and activated and we follow the next word true, that means the fire evacuation plan is initiated and the people within the building can evacuate, which will lead to minimal loss of life and minimal damage to the building. Now, if you follow all the words that say false, which means the opposite has happened, and the fire alarm sounds are not working, the sprinklers are not working, which means the fire evacuation plan has failed, and it will then result in severe loss or damage to the building. Okay, so that is an example of an event tree analysis. Okay. Very straightforward. It's basically you starting with an activity, identifying the steps in your fire evacuation plan, and ensuring that it occurs. If it does not occur, what is the negative that could go wrong, which is obviously all the false words in this table figure. Okay, so the fault tree analysis, which is obviously called FTA. Okay, let's go down.
Sorry, Angela. Your screen is blank. I can't see anything.
Is it blank for anyone else?
No, might be her technical error.
Okay.
Yes, even for me, it's blank from the start. I'm just hearing what you're saying only now.
It doesn't look like it's a lot of people. If you are experiencing it, it's obviously a problem on your side because everyone, well, most of the students can see my screen. Okay, sorry about that. There's nothing I can do to assist you. Okay, so the just please make sure you guys are muted. Okay, cool. All right, so let's move on to the what is this called? The FTA, fault tree analysis. Okay. Let me just move that over there. Now, the fault tree analysis. Okay, the example they are using here is the kettle handle burns operator. So, what is that activity initially? It is actually you are going to the kitchen, you are going to boil the kettle so you can make some coffee. Okay, now you've burnt your hand while.
Angela,
Yes.
are we going to have a time to ask the questions?
If you heard me at the beginning, I said at the end of the session.
At the end of the session?
Yes.
Yeah, you mustn't go fast because we have a lot of questions to ask you, please. It's Godfrey.
Okay.
Sharp, sharp.
Okay, so you burn your hand, okay, on the kettle. Now, it's saying here, okay, example of the fault tree analysis, okay. So it is saying here, we are going to start from the bottom up, okay. The kettle handle burns the operator. Why is it burning the operator? Perhaps it was broken, okay. Perhaps the design of the kettle had an initial breakage, or it was had a weak material used to build the kettle, okay. It can even say that the handle hollow, allowing water inflow, okay. The kettle could not have been sealed properly. So when we talk about fault tree analysis, we're going to look at what went wrong with the device or the tool used that resulted in you burning your hand. Okay, so burning your hand, holding the kettle, could have been from the kettle handle being broken, or the mitten or the glove that you were wearing to use to hold the kettle was perhaps too thin. Okay, it was not the correct material. Okay, so we will look at the faults behind leading to that initial burn. Okay. Let me see where we are here. Okay. So now, I'm just waiting for it to load. Okay. And then there is obviously the bow tie analysis as well. All right, which also falls under the tree event. Okay, the tree analysis. Okay, so here's another nice example, bow tie analysis, right? Very visual. Okay, you have your tire puncture. Why? Perhaps there was a foreign object such as a nail got caught in your tire, and now your car has a flat tire. Okay. How did we identify the car as a flat tire? Perhaps we were driving and we felt the car wobbling, or perhaps we were looking at our tires before we got in, or the car, perhaps you're driving a nice car and your car turned on a warning sign to say you have a flat tire. Okay. Okay, and then the next one is human reliability analysis. Okay. So the purpose of this human reliability analysis okay, is a complete field of science with many different methodologies, tools, and techniques dedicated. Okay. However, it is listed and described in this chapter owing to the influence of human error. So here we are going to be looking at the human error. Okay. So let's go to its example. All right, again, we are back to the cutting a towel into the correct shape to fit the floor we are tiling. Okay, so what are the steps we are then going to do to cut this towel? We're going to first purchase the towel. We're going to measure the correct measurement we need to cut the towel to. Okay, we are then going to proceed to get the towel cutter. Okay, and we are then going to actually cut the towel. Okay. What are the steps involved in getting your towel? It means you need to go and choose the correct towel and you need to take the towel to work. Okay, so this is pretty self-explanatory. The first step in the reliability. So it starts off with identifying your methods, okay, and then you move down to identifying the errors, okay. So it starts off by saying you can identify the error by selection or omission, okay, or sequence. You can see here they've specified what error type belongs to each task at hand, okay, and then obviously the effect. Okay, and to find those error types, just scroll up in the textbook. You'll see it over here. Okay, these words are then selected dependent on the task at hand, and they are then inputted into the error type. Okay, and then let's move on to the last one, which is called, oh, was that the last one? Oh, it was. No, did I miss something? Yeah, the last one is called the cause and effect analysis, or the fishbone analysis, okay. It was originally designed for design quality defect prevention, but has many other uses and is often used in safety engineering. Interesting. Okay, so let's look at this example here. It is event where an operator's hand is burnt on a kettle. Okay, back to the kettle, making more coffee. Okay, so here it's going to take into consideration the people, the environment, the materials used, the steps involved, and the actual machinery used. Okay, what actually led to the operator burning their hand? As you can see here, more to the right. Why do operators burn their hands on the kettle? Perhaps if we look at the people error, here the person is not using the kettle properly. Perhaps the person has poor training and they're not aware that the kettle is hot. Okay, what hazards could the environment pose for the person to burn their hand? Perhaps the person was working under pressure, in pressure involved working environment, and they were not following the correct procedure. Okay, so then what is the material of the kettle? Perhaps the material for the kettle is incorrect, it's not isolated properly, and it is perhaps old and damaged. Okay, that is what the cause and effect. The cause and effect hazard analysis will use the looking at the people, the environment, the methods that you follow, the machinery used, and the material. So out of these 6 different tools used, and we've just discussed the 6 different tools, the most popular ones that you will perhaps use in your industries is going to be the first one we spoke about, which was the what if analysis, and the last tool, which is the cause and effect analysis. Okay, those are the 2 most popular ones going to be used in the construction industry and most industries that you operate in. Okay. So the next section just talks about the selection of a hazard evaluation method. Okay, and this is a brief section. I'm not going to go over it. It's just for you to go and read as to identify which evaluation tool you are going to select for that specific hazard tool that you've selected above. Okay, so that you can go over in your own time. Okay, so we are now going to be moving on to first aid. Okay. Or do you want to do a question now, Q&A session now, and then I can upload a recorded video on the first aid unit. What would you guys like to do?